Hello everyone, I hope you're having a great day. Today we are going to be talking about exponential growth and decay. I know I've already talked about that in the last two lessons, but today we're just going to go a little more in depth with it and do some application problems with them. So first, for just going over some basic definitions and facts. An exponential function, like we talked about, can model the growth or decay of something. In exponential growth, decay, / neither, each part of the equation represents something specific. So I'm going to write this in terms of word problems and what these mean. So the A, that's always going to be your starting amount. So whatever you start with and what's growing or decaying. B is what you are doing to your problem. So what I mean by that, am I doubling, tripling? What's happening? And then the x is going to stand for our time, and we usually use the variable t here. And so this can look different for exponential growth and decay, especially if we're looking at a percent increase or decrease, which is what our first few application problems will be dealing with. So for exponential growth facts, b, the growth factor, kind of like what I already talked about in other videos, is always greater than 1. The growth factor b is always 1 plus the percent rate of change. So what I can write is y equals the start value, which again is just a, times in parentheses 1 plus the percent rate of change r, raised to the t power, which is my time. And here r is equal to the rate. And special note here is we always write the rate as a decimal. In our word problems, they will be putting this as a percent, so we're going to have to change that percent to a decimal. And if you remember, let's say I had 11%. To change that to decimal, I'm just going to take this decimal point and move it back 2. So that would be the same thing as 0.11. But we'll get some more practice with that in the next few videos. Exponential decay facts, on the other hand, my decay factor b is always going to be between 0 and 1. So a fraction or decimal between 0 and 1. The decay factor b is always 1 minus the percent rate of change. So here y is equal to the start value a times 1 minus r raised to the t power. Okay, that's it for this video. You can go ahead and move on to the next one.